Some of them come really fast soon.
Be patient, it will arrive. Maybe about June. Be strong. Right, we'll continue now. Okay. Mushreef? Continue. So if you can write this down, this is what we're going to have a look at now.
The predicted grades are for ourselves or are for the university?
What do you mean?
The predicted grades
Yeah.
are for the predicted grades that you give.
Yeah, you can know them.
They are not for the university, or they are?
They are.
Yeah, but if you get a class,
No, but they will give the conditional offer before the final results or after the final results?
Conditional offers before.
And if they don't give, that means no.
Yes. Why did you get your predicted grades?
No. I can feel that.
Yes, indeed. When do you have Isabel?
Today.
What time?
After 3 hours today.
So you have 3 hours to think about your fate and your future. Huh?
Not enough.
Okay. Did you write this down?
Yeah.
That product? Yeah. Okay. Right, so now we're in a position to multiply vectors in a certain way. So if I have a vector, let's call it R1 is equal to x, y, z1, and then R2 is equal to x2, y2, z2, then R dot R2, the multiplication, we define it like this: x1, x2 plus y1, y2 plus z1, z2. What you notice critically is that we start with two vectors, but we end up with one scalar. So this dot product, this dot multiplication, takes you from vectors to scalars. There is another type of multiplication called the cross product, which is not on this course, which takes you from vectors to vector. You will study this at university though. Okay, so this is the definition, and we'll look at why this is useful now. So if you can write this down, please. It is. Got that? Yeah. Okay, let's have a look at some of the questions you have here. Okay. I wonder if I wait until the next lesson to tell you why the dot product is important. What do I say in this lesson? Okay, so let's have a look at a simple example. Let's calculate the dot product of 1, 2, 1, dot 2, 3, 4. So it's 1 times 2 is 2, plus 2 times 3 is 6, plus 1 times 4 is 4, which is 12. Yeah? Okay, you try this one for me. 2, 3, minus 1, dot 0, minus 1, 2. 0 minus 3 minus 2, which is minus 5 then. Yeah? Got that okay? Alright, so let's have a look maybe at a harder one here. Or actually, maybe we should have a look at some properties of dot products. So first thing is, if you have vector A and you dot it with vector B, that will be the same as B dot A. And likewise, if you have vector A dotted with B plus C, that will be the same as A dot B plus A dot C. Yeah. So it's a lot like multiplication. It has the same properties as multiplication. Probably the only difference is there's not really a vector which we can call 1, that when we multiply it by A, it still equals vector A, because that's impossible since the answer is always a scalar. So this multiplication is a lot like normal multiplication, except it has there's no 1. You can't say 1 dot A equals A, because it has to equal a scalar, not a vector. So we can't really do that here, but most of the other rules are the same. First one, A dot B is B dot A. Second one, the distribution, A dot B plus C is A dot B plus A dot C. These are true. So let's have a look at a more difficult example now. Can I scroll down? Yeah. Let's say A is, I don't know, 3/5 and 4/5, and B is 5/13 and 12/13. Okay, so just to get things started as part A, I want you to calculate the magnitude of A first, and then part B, I want you to calculate the magnitude of B, just to get started. One and one. Okay, and now part C, I want you to calculate A dot A, and then part D, I want you to calculate B dot B, and then part E, A dot B. Yeah, it's going to be, yeah. And yeah, not 1. Not 1. Which I just wanted you to see. Okay, can I scroll down? Yeah, okay. Here's another one now. Let's say A equals 3, 2. No. 3 over 5, 4 over 5, and B equals (4/5 minus 3/5). Okay, so part A here, I want you to calculate A dot A, and part B is B dot B, and then part C is A dot B. But there's more now. I'm not just going to do this. So anyways, you actually did A dot A already, it's 1, but B dot B is not 1 here because of the minus. Well, actually, no, I think it will be. Could be 1 still. Why don't you calculate it?
It's squared.
Yeah, so it's 4/5 times 4/5 plus, minus 3/5 times minus 3/5. So here, this is 3/5 times 3/5. It is 1, isn't it? Yeah. But what is A dot B? This is not 1 for sure. Zero, okay. So, we love vectors like this. True. If A dot A is 1 and B dot B is 1 and A dot B is 0, these are really convenient vectors. So I'll continue the question to show you why it's convenient. So part D. So let's imagine we have some vector, we'll call it OR, and it can be any vector we want. Let's say 5i and 12j, for example. So this is some vector like this. You know you can write this as 5i plus 12j, and the I vector is on the horizontal and the j vector is on the vertical. But is it possible to write this instead of as i's plus j's as maybe some a's, which are unit vectors as well, plus some amount of b's? So what I'm picturing here is you have some vector OR, and you can say that's 5i's plus 12j's. But we have these two vectors, I'll just call it like here, something like A, and here, for example, something like B. And I want to know, can I write my OR instead of 5i's and 12j's as maybe like, whatever, so many A's and so many B's. In this case I need minus B, so like maybe 2 A's minus a B would make it's something like this. I don't know what it is because I have to work it out, but my point is still this: instead of using i's and j's, can I use different vectors like a's and b's? Do you get the idea I'm getting? So what I'm trying to do is I'm trying to write OR as so many a's plus so many b's. Can we do that? We can. Watch what happens here. If I dot both sides by A, or dot A equals lambda A dot A plus mu B dot A. What's B dot A? No. 0. What's A dot A?
1.
So you have a very easy way to work out lambda. Lambda is just A dot OR. And here's the A, and here's the OR. So can you give me the lambda, please? And likewise, 63/5. Likewise, give me the mu. The mu would be B dot OR. And here is the B, and here is the OR. So what we're saying now is OR is 63/5A. What was my A? 3/5 and 4/5, minus 16 over 5, 4/5, and minus 3/5. So what I've done is I've rewritten or instead of 5 i's and instead of 5 i's and 12 j's, I've written it in this form. But it's still the same vector, because watch, I'm going to prove that it still simplifies to the previous vector. So if I multiply this by 63 over 5, what's that? That's 189 over 25, is it?
263 multiplied 3.
Yeah, what's 189 over? Which simplifies to? Oh, well then I'm afraid you must have made a mistake here with your dot product. Three-fifths times, what was the first part? 5 plus 4/5 times 12. Oh no, I apologize, it is 63 over 5. Oh, I'm not finished yet. I still have this part here too. So what did you say it was? 189 over 25, and then the next one would be 60 and 60 is 120, 240 and 12, 252 over 25, 63 over 5 times 4 over 5, minus, 63 over 5. You have a calculator, Mir, type it in please. 63 over 5 times 4 over 5. And Sharif, you can do the next one, 16 over 5 times 4 over 5.
Yeah, it's right, 252 over 25.
Okay. Mir, you can do the last one, 16 over 5 times 3 over 5. So what's this one? With Sharif, you were doing this one.
Minus 64 over 25.
And then the last one.
48 over 25.
Okay, so let's simplify this. 189 over 25 minus 64 over 25. Yeah. 5, and then I'm sure when you put the other two together, you'll get 12. Yeah. So what we've successfully done is we've rewritten the OR as, what do we say, 63 over 5 A's minus 16 over 5 B's. So what you're doing here is change of base. Instead of using I's and J's, you're using A's and B's. And it's very easy to change the base, like I said, when the relationship between A and B is the following. They dot together to make 1 by themselves, and when they dot each other, they make 0. When that happens, it makes it very easy to find the lambda, because you can just dot by A to get the lambda and dot by B to get the mu. This is something that you'll do more of next year, but it's a useful, it's a one reason dot product is useful. If you're wondering what it means to say A dot A equals 1, I hope the previous example could give you a clue at what it means. What do you think it means to say A dot A is 1? Well, it means the same thing as saying its magnitude is 1. If the dot is 1, then it's a unit vector. If the dot is 1, it's a unit vector. So here A and B are unit vectors. But does anybody know what it might mean to say A dot B equals 0? Now that's actually in the next lesson, but I wonder if anyone's seen it before.
because of the
Not quite opposite signs, you're thinking along the right lines though. It's two vectors that are perpendicular.
Steven,
Yeah.
how do you get the lambda? M multiplied R. What is the R?
Huh? How did I get the lambda? I started here and I dot by A.
Yeah, I know. It's unit R multiply A equal lambda.
No, or dot A
R dot A
equals
what is
lambda.
the R?
Here it is here. See, I'm sneaky. I gave you the information. So sneaky. Okay. So the reason we love these vectors is because they're unit vectors and they're perpendicular, which makes them very convenient for changing the base. Okay. There's a lot here, if you can write that down, please.
How did you get 63 over 5 minus 6A minus 16 over 5B?
I did, this one was A dot or, and this one here was B dot or, and I give you the A and the B, and I also give you the or. There was stuff on the bottom? Oh yeah. That's just, that's 5 and a 12 down here. Actually, I should just write that over here. Yeah. Can I close that, guys? Yeah. So let's see what else we have here. Well, there's a small typo in the very last question here. That should be mu A plus lambda B at the very end. Okay, so if you can start these now, just for 10 minutes, and then what have we got next? Angles then, so we'll do that next time then. Questions are not that difficult. I think you'll be okay with them. Yeah, so I just need to close the screen. If you can open them up on your phone. Or if anyone wants to take a picture, they can. I'll zoom out. Does anyone want to take a picture, or are you just going to open on your phone? Okay. Closing? No, you're taking a picture? Okay. You'll have to do it in 2 halves. Tell me when you have this half. Right? Second half. Yep. Can you get the light, Adnan, please?